I need to design a bamboo farm. I get that it's maybe not the most glamorous resource in the world. In fact, it might just be the easiest thing to farm in this game, but we're going to do this thing anyway. We also don't really need all those technical systems, design methodology steps that we've looked at so far, but I think it'll be good practice for the weird mechanics driven big dogs. If you didn't know, this is episode 1 of the series, though it is technically the second video. But yeah, last time was just basically 10 minutes of me nerding out about like one page of a random textbook I read. So if you don't feel like going back to watch that video called episode 0, that's fine. We'll be hitting most of the design process points today anyway. So yeah, let me officially welcome you back to... Alright, let's head back over to the Minecraft engineering world for a quick refresher. This is the process we looked at last video. I've moved these 2 pillars up there just to be less annoying. Just as a quick recap, step number 1 in this process is what problem am I trying to solve? Step 2, what are the subsystems? Step 3, what are the options for each subsystem? Step 4, choose a combination that makes sense. 5, build and test. And then finally 6 is iterate. This concept is loosely based on some quite common systems engineering concepts. In the real world, it's slightly more complicated than this, and each step kind of has sub-steps. But I think what we've come up with here should be good for anything Minecraft related. Like any good design process, you've got to start off by defining the problem. And no, in this case, it's not just I need bamboo. This whole thing started because I had 2 separate needs that could be serviced by bamboo blocks. First, I needed a super smelter, which the bamboo would be fuel for. Second, I needed some auto refilling storage system for every crafting recipe that asks for bamboo. Don't worry, we're not designing the auto crafting stage today, though I might tackle that in some separate video. But yeah, let's start off by defining the problems here, and then I'll add a little twist to each to make it a little bit more interesting. So I've made us a little extra board space here, and I think we can use this for general note taking. So the 2 problems that I had spoken of before, problem number 1 will be that I need a fuel source for a super smelter. We can also look at super smelters in another future episode, but for now, all we need to know is that to be able to feed a super smelter, we'll need 1 double chest of bamboo blocks. Make this a little bit more fun, I have added an extra constraint to this one as well. So I want the output of this farm to be redstone controlled. Basically, I only want enough bamboo items to be able to fill up this 1 single chest. I'd rather not destroy any extra bamboo or store any extra bamboo. I just can't be bothered. So we can't have this making a surplus. I need to make an exact amount of bamboo. Because of that, we'll need a farm that's on the smaller side, but has a more consistent rate, as opposed to a larger farm, which is more focused on total yield or total numbers per harvest or whatever. And then problem number 2 is I need a larger scale farm to feed a storage system that autocrafts a bunch of wood recipes. I guess we'll call that wood system thing. But I basically want all the recipes that you can craft from bamboo just to be available at any time, so I can just take whenever I need. A good practice when designing is to start with a broad problem statement and then continually narrow it down until it's something you can work with. So instead of thinking I need an auto crafting system, let's narrow it down for now to just I basically need 1 hopper chain that's carrying an absolute boatload of bamboo. And in this case, more is better. Realistically, you could probably use the same farm design to achieve both of these goals, but since we're trying to broaden our horizons here, I'm going to be adding some random and fun constraints to a lot of these projects. So yeah, we'll definitely need 2 different farm designs to achieve what we've laid out here. Now, step number 2 is something you'd kind of handle in your head a lot of the time, but since we're already needlessly overcomplicating everything, I say let's dust off the old graphic design software, or well, in my case, Google Slides, and then head up to the old classroom in the sky. It is officially time for the functional decomposition. Yay. I mean, I'll try to keep this as short as I can, but come on. This is going to be fun. All right. First of all, we need some bamboo. So this is either going to go on a block of dirt or on a block of mud or maybe grass if you're fancy. There's no need to break this up any further than that. This will kind of just grow fine on its own, but we do have ways of speeding it up. So Still within the same subsystem, I'm going to add a dispenser, maybe even more than one, and whatever redstone is required to make it work. So these will be dispensing bone meal, and I'm calling the bone meal source, or whatever farm will be producing that, out of scope. All right, I know this got complicated fast, but we're not designing anything here. All I've done is I've said that if we think we need a dispenser with bone meal, we can handle the design of that as part of this subsystem. So we're calling this whole thing the growth mechanism, and you'll see all the different forms it can take during step 3. Next up is a detection method, and this is probably the easiest one to deal with. We just need some method of detecting that the bamboo can be harvested. This can also be more complicated than you would think, though maybe that's just me being me. So feel free to go as simple or as complex as your heart desires. I do feel the need to mention here that any hopper clocks or other timing mechanisms would fall under this subsystem, since at their core they're kind of just predicting when the growth will happen. All right, once we know that the growth has happened, we obviously need to harvest. This one is where you can have a lot of fun, I think, so let's just put a piston down for this one and kind of move on. Also note that we're already thinking about all the interfaces between these subsystems as we go. All right, you have a bamboo plant as part of the growth mechanism. You know that it's grown because of the growth detector. You've harvested it, because if you haven't, you've probably skipped a step. So at this point you'll have a bamboo item just kind of floating around. So the last subsystem we need will be the collection method. This one is no fun, so when we get to it later, honestly, just click off the video. All right, there we go. A functional bamboo farm broken down into its parts. Before we move on to the design section, I feel that I do need to say that if you're just learning how this game works, or if you've never tried to design a farm and this has given you some ideas, please go and try them out. If they suck, they suck. That's just how it is sometimes. But I promise you, the feeling you'll get when they finally don't suck is one of a kind. All right, that's enough of that. So I think we will head back down now. All right, step number 3. What are the options for each subsystem? So I reckon it's finally time to do a little bit of design work. At this point, I haven't attached any matrix to any of the subsystems, and I don't think I'm going to for this one, at least. I don't really care enough. I'm just going to kind of go with the cool factor. But if you want to, feel free to. This is also kind of where a lot of the structure breaks down, because this is where we actually have to kind of think and figure stuff out, you know. So let's get started. I'm going to be building for the rest of the series behind here. So I think I should try and get rid of these villages first. And I think we can just get it started so long. Sorry, guys. I'm really sorry, man. Oh, shame. Poor sheep. Oh, well. That should take care of most of the work, right? Take your water away too. We're kind of going to be doing a lot of building here, and you don't want stuff to just be organized randomly. So is that thing still burning, or did it just kind of give up? Nope, they're dying. So, okay, so the idea was you have a platform. We do all our experimentation and final build on that platform. Everything's organized, and then we push a button, and that kind of gets filed away in some structure. So we might have to do that, you know. It might be worth doing, actually. I'm really liking that idea now. We can just transplant it into the kind of massive farming matrix afterwards. I'm going to look into that. I think we should do that. Right. This is the vision, right? This is going to be our little build block. Everything we build is kind of going to be within this area. If I need to expand upwards, I will. And if I need to expand sideways, backwards, or whatever, I will. But I think for now, this should be okay. So the idea is every episode we build in this area, and then we can use structure blocks to go remove it from here and go put it somewhere else. And I think we'll work on that maybe at the start of the next episode. For now, I think we should just get the floor filled in with glass, and that should be pretty easy to do. Do I like that texture? We can try tinted glass. Ooh, I think that's much better, though we might get mob spawning down here. I think I left clicked, so if I right click this, set air. Oh, okay. Cool. There we go. All right, we have our little build platform and pit of despair. Well, I mean, it's quite nice and blue down there. I mean, pit of happiness. All right, we can officially get started. Subsystem number 1 is going to be the growth thingy, and the simplest this can get will just be a single bamboo plant. Let's get some bone meal. On top of a dirt block. Can't really get much more simple than that, can it? Next will be a dispenser with some bone meal, and it's a single dispenser, so we'll need to power this somehow. A common way of doing that is with the old chicken farm clock. That's very annoying. I thought that would switch it off. Maybe if we do this, that switches it off. That switches it on. All right, now you have a little bone meal dispenser. All this is doing is making the bamboo grow. All right, option 1, this thing on its own. Actually, I might move this forward slightly. And then I think we go backwards. And I'm also just going to kind of think about advantages, disadvantages as we go. Obviously, there's a lot of clocks you can use to make this work. And I think the speed is settable through that repeater. But it would likely be tileable. Ooh, they're still burning. Pretty light. Anyway, you could think of a design that's tileable, but it would be tileable laterally. After this, the next thing we're going to consider is a double bone meal design. I'm not going to go further than that because I have no clue even whether 2 is any better than 1. But part of the beauty of this whole process is if we are in a situation where we care enough, we can just come back and test. But for now, let's just assume that 2 is better than 1. We're going to do an observer clock for this one, including the on and off switch as part of this. You're going to want to power both of them through one block. All right, if you didn't know, you can put 2 observers facing each other. That'll make it pulse like this. And then you shoot out bone meal and your bamboo grows very fast. So I'm going to do a little test. If we power just the one and then we put the clock on, we're gonna eyeball this, okay? We're gonna eyeball this. How fast does it grow? Pretty damn quick. Okay. Now, this is... Oh, can't do that. That's switched off. So now, when I activate this, both will be on at the same time. That's okay, that's literally double the speed. So maybe it's not exactly double. How tall do these things grow? 11, 12, 13. Don't know if that's the max height, but that's the max height that this thing is growing to. We're going to take this out and we're going to put 10 in each. I want to see if any bone meal goes to waste by there being 2 dispensers. So just a quick little test just to kind of evaluate these different things as we're designing here. That used 7. That used 6. Did I do that wrong? I must have done that wrong. Okay, there's 10 in each. We'll count how much it grows. Let's activate this. There's 10 in each. Okay, 5 and 5. So it used 10. Okay, well, we'll just add 1 to the total. Alright, today we learned that bone mealing bamboo can grow it more than once. Who knew? That grew it once. That grew it twice. That's a new little fact for you. I had no clue that this was the case. Bone mealing bamboo makes it maybe grow more than once. Anyway, this seems to be the fastest design, the double dispenser. Obviously, it's going to use the most bone meal. And I get the idea that it uses bone meal at faster than hopper speed. Actually, in fact, it likely does. I think we'll sort the details of that out during the final design. But yeah, this is the fastest, but not scalable at all. The second fastest, but you can only scale it in one direction. And then this is the slowest, but you can scale it as far as you want. Obviously, you can put these modules next to each other as much as you want, but you can't put them right next to each other. It's not one wide, is what I'm trying to say. All right, let's get onto the second subsystem, and that will be the growth detector. And I think hopefully this will be the easiest to sort out. Detector. No clue whether I spelled it. Okay, it looks spelled right. I wanted to call that the growth thingy, but I think I've already called this the growth thingy. Yep, okay, so that won't work. Right, we need a way of detecting growth. Right, the first option we have for a growth detector is just a fast clock. So actually, let's break this. Okay, sticky piston facing downwards, iron off. Yeah, I know it doesn't detect any growth. What it does do is it will continuously fire whatever you want it to fire. So whatever your growth mechanism is, or sorry, your block breaker, or the way that you're going to break the blocks, if you want that to be running continuously, and there are farm designs where that does work, especially this one actually, because this will just grow like no one's business. So fast clock, one way to do it. Second way is a hopper clock, and let's see if after a few years I can remember how to make one. Might be pretty close to here. Does the sticky piston go there? I think he's a right? Ooh, this one. That makes no sense. These go here. And then you just put a stack of items in there. You control the timing by putting whatever amount of items in the one side. Quick explainer, if you don't know how hopper clocks work, this detects there are items in this hopper. The comparator is just saying, yes, send a signal. There is stuff in this thing. The signal is sent through to the piston. Piston then extends, pushing the redstone block, locking this hopper. So all the items from one goes into the other while it's locked. So this one is counting down, pushing it into this one, and then it pushes back. Probably the worst explanation on the internet of, right, this is basically just a really slow clock, and this is useful where you have a lot of stuff that needs to grow. You would need to wait a decent amount of time for everything to grow before you activate your braking mechanism. So yeah, that's where this becomes useful. All right, the next one is a husbandry. What? Oh, apparently L is advancements. Whatever happens in the block in front of the observer, if something happens on it, it'll send a pulse straight through here. All right, now the last thing is I need to run a quick experiment here. I don't know how skulk sensors work at all. Let's see if I can detect growth with some bone meal. The act of bone mealing something detected it, but does it work just on its own? I'm not sure that random tick speed is responsible for plant growth. It looks like it's gone faster. Okay, natural growth does not set off a skulk sensor at all. I think that's 3 by default. Let's pop on a big old sign that says does not work. Well, it was worth investigating. So what we have so far is, how far am I going back here? Hold on. Okay. Quick recap. Fast clock wouldn't be my favorite. Slow clock. Observer to detect when a plant has grown. Boilers. This is my favorite. And then the skulk sensor, which does not work. In my opinion, there's not a lot to evaluate at this point. I think which one you use is gonna depend a lot on which other subsystems you choose. So we're not gonna be kind of optimizing anything in this space. So I think let's move on. Subsystem number 3 is the bamboo breaker. All right, I've just gone ahead and placed our bamboo plants. The first option you have, and these are the ones involving pistons, or the first 3 involving pistons. This is just a piston that pops it off, and it could kind of fly anywhere. Second option you have, the reason why you want to classify this as 2 separate options for you to have is there can be times where you run into kind of space constraints where you have power coming up here and it's convenient to have the piston in this position. There will be other times where it's more convenient to have the piston in this position. So yeah, this is just a good option. Third option you have, this is the fun one, is slime blocks. That kind of yeets them out of the way, and you can guess which one is my favorite. That's useful in the sense of, watch this, for this one. They've kind of fallen all over the place. And slime, the issue with the bamboo falling straight down, the slime doesn't have that. Whatever bamboo is in front of it gets yeeted out of the way. All right, since we've been doing some experimenting anyway, and we are looking at ways to break bamboo, I want to try something. Yeah, it's TNT. I want to see if this works. Ooh, pretty light. All right, bombs away. That's going to break the dirt, isn't it? Oh! Just me, or was that kind of decent? I'm not considering this as a legitimate solution. Right? Of course I'm not. I would never. It's bad engineering practice to throw a concept out based on feeling, even if that feeling is it's going to be very inconvenient and it's going to go horribly wrong. So let's move on to the last method that I was able to come up with. Sure, there are many, as always, and that would be a flying machine. A flying machine at its core is a piston connected to a slime block, and then another piston connected to another slime block. And what you want is to actuate the pistons, first one, then the other, then the one, and then the other. All right, I think that's as easy as you can make a flying machine. Obviously, I don't want to be sitting here with levers making it go. In the context of a farm, you'd have arms going out like this. And you would have the bamboo growing on this block right below it. And then I think you use observers facing this way. And then you... Alright, I think that works. And then you just need to be very quick about it. And then they bounce like this. Apparently I can't click fast enough. Those are at least the options I could think of. So, yeah, if you've got any other ideas for actually any of these subsystems, you can put them down below. Some of them really didn't actually need to be mentioned here, but they are options that I thought of in the kind of design process. And I think when working on any design, it's important to consider any idea, right? Is always a good way to go about it. All right, next up is subsystem 4. I've somehow ended up going a little like a snake pattern thing here, so we'll just keep going. Now, this is an interesting one. Looking at my notes here, there's an option I really don't want to try at this point, but we have to, don't we? The reason I don't want to try it is because I have no clue how it works. I'd have to do research. We don't do that here. Option numero uno. All right, imagine your bamboo plants are kind of in this area. You are breaking them from this direction. They will sort of go this way. Make it a little bit higher. Okay, cool. One of them fell into the water stream. You'd ultimately have hoppers at the end of this chain. We're calling that a downstream system, and by extension, we're not going to be designing it now. But yeah, your first option would be to just have the items fall into a water stream. And the ice just kind of makes it go along faster if you want to wear. Your second option is to collect items with hoppers. Now, there are a few things to keep in mind when looking at this subsystem. The first one has got unlimited capacity. Any items that fall in it will flow along. Even though you might have bottlenecks at the end of the stream, actually carrying the items, there's nothing limiting it. A hopper has a set speed and a set capacity. The speed that hoppers carry items at, I think, is called the hopper speed. So it's basically how many items we can get rid of, or how many items we can carry around in a given time frame. You might have farms, or you might have heard that farms are double hopper speed or triple hopper speed. That just means it's producing enough items for you to need 3 hopper chains next to each other to carry all the items away. That's something to be aware of. So, another thing to be aware of, hoppers cannot pick up items through blocks. That item is staying up there. So what you can consider is a block like mud, and items will go right through the mud, and you can plant bamboo on mud, if you're wondering. So if you break a bamboo item and they fall on this mud block, and of course they don't fall on the mud block, but if they do not fall on the mud block, they'll go through. If they fall on dirt, they won't. All right, the next option that we have is hopper minecarts, and I have to confess something. I have footage of myself building a hopper unloader for 30 straight minutes, and then once I finally figured it out, I just want to say it, I've never built a minecart hopper unloader, never mind designed one. I fully designed a working unloader that is off by default, and it only switches itself on the event that a hopper becomes empty. So when the hopper underneath the hopper minecart, when it becomes empty, it generated a pulse to send the hopper minecart off again. Now, that would be useful in situations where they are guaranteed to be items over the blocks on the rails. I don't know of a lot of farms that work like that though. So yeah, I think I just wasted 30 minutes. So let's simplify it a little bit. All right. My main issue with this kind of system is the fact that you have to classify the unloader as part of the system, because there will be some redstone, some complexity. And while we are technically looking at a collector, without this unloading portion, this thing can only collect so many items. So normally we can consider stuff like this out of scope for this, for example, and this, for example. But that's because the things that are out of scope aren't too complex or aren't strictly necessary for it to perform its function. But this can't cart items away from anywhere unless you can have some sort of way to empty it. And then you can just give it a little pulse and it'll go collect again. Now, in this specific farm, you will know when the harvest happened because you have a detection method. So we don't need a a continuous thing where it only stops while unloading. I've seen many systems like that before. I haven't actually looked at how they work or what they use to work, but I've seen farms that need that on principle. I wasn't able to design one in the 30 minutes. I'm sure it's very simple, but it's kind of just how the series works. If I can't figure it out here, then I'm not going to Google how to make it work. But yeah, luckily for bamboo farms, it doesn't really matter because you will know when the items are going to be harvested, so you will know when to send those off. Now, the option I was dreading is allays. I've got no clue how these guys work. Can I give you an item? Take an item. Or do you have to give them one? Oh, and then they go pick them up? Okay. As far as I know, you use note blocks. Are you gonna... I can't punch them. Maybe we can just do a quick clock. Let's give you some bamboo, just so we're kind of accurate, right? Take the bamboo, please. Do I need a new one? How many can he pick up? Did he throw that to me? Alright, it's research time. Let's do Minecraft Wiki, because I've got no clue how to make them. I thought it was something to do with note blocks, but alright, I want to have a little look at the wiki to see what they can do here, because I think we've decided that the wiki is the only acceptable point of research. So allays can be found surrounding pillager outposts. That I knew. Allays can be duplicated and bred by playing a music disc in a jukebox with allay nearby and then clicking the allay with an amethyst shard while they are dancing. Flies aimlessly until you give it an item. That part I could figure out. The allay starts following the player and seeks out dropped versions of the same item to deliver them to its player. Okay, that I saw. An empty using hand is how you take it away from it. Okay, that's good to know. If the allay has a note block within 16 blocks of its location while delivering items, it will instead deliver its items to the note block and then spend 30 seconds around that particular note block seeking items around it. Okay, so what I get from this is the way to get it to do what I want is to take the glass away from the top. So let's have a look. Right, we have an allay looking for bamboo. So I think the trick now is to open this up so it can hear it. I believe we can nudge this, and a part of its hitbox is now over all this stuff. So that ends up there. 1, 2, 3, 4, 5 stacks. Oh, it just chucks it randomly. It throws items like a crazy person. It's taking a very long time. I think this is probably a bad design from my part here, but why does it like just chuck them next to it? I don't know. Okay, all right. No allays is what we've learned. But it was a good experiment, I would say. All right. I can't think of many more ways to pick up and transport items. I'm sure there are, once again, in the comments, but I think that should do it. I think that's all the subsystems we had looked at. If we go back with all these, with all the options that we have, can we have a hopper chain of bamboo flowing through it? Sure. And a redstone controlled super smelter. I think we've got the building blocks that we need. And if in the process of building an actual farm out of these, we discover something, then we discover something. And I have some allays to murder. Why are these guys... Ah! Come on, come back. Why is this the most durable mob in the game? Just die. Now that the allays are dead, I think we've got the building blocks, and I think we can make something workable from this. I have no clue how that village is still on fire. Well, I guess it's officially time to choose a combination that makes sense. And you're gonna have to do this for each of the problem statements. So I think we start with super smelter fuel. So that'll be 1 double chest of bamboo blocks, and it's redstone controlled. I am questioning my sanity right now. I'd never thought that building a bamboo farm would take this much time, but here we are. Let's get started. What we want to do is we want 1 double chest filled with bamboo blocks. I don't think I'm going to iterate on this in the sense of making it more compact, which is what you would normally do, or at least it's what a lot of people would normally do. I'm mostly going to iterate in terms of the subsystems I choose. This is not something we discussed during the subsystems because this is solution specific or this is problem specific, but we need bamboo blocks feeding into this. That means we need a hopper. We're going to go with 4 to start off with. I will reduce or expand on this as it becomes necessary. We need hoppers feeding into the crafters. Actually, let's do that from the top. Let's see if dust can power all of them. Turns out it couldn't, so I've just pulled it back and added target blocks. There's almost certainly better ways to do this, but this is what we have. We know this farm is going to have a pretty high rate, so we're going to go with this water collection system. I'm pretty sure this is the fastest mode of transporting items. Okay, now what will happen is any items thrown into here will align itself against this chest and then be pushed across all of these. In my opinion, it's nice to design from the solution or from the problem backwards. So I want this to be full of items, bamboo blocks. This is going to make the bamboo blocks for us. If you weren't aware, nothing can be crafted from bamboo in the filling order. So crafters fill in from left to right, top to bottom, and nothing can be crafted from bamboo until you hit the block, at which point the block will be crafted. So lag wise, it's maybe not the greatest thing ever, but you can switch off this. I'm not sure how bad the lag is for redstone nowadays or how bad it would be to have this running, but we'll always have the option of turning this off when the farm's not running. But when the farm is running, we want to be getting the stuff in and out as quickly as possible. All right, so we want bamboo to be coming in from this block here. Let's get to designing the actual bamboo growing portion. These are the options we have. In my specific case, I have access to bones, so I don't mind using a lot of bone meal on this. I just want a large amount of bamboo output as quickly as possible. I think we're going for this design. Now, before we do anything, I need to check whether hopper speed is enough or do we need double hopper speed. Basically, we're trying to see if this empties or not. Okay. It was running down. As you can see, a lot of these decreased, but I think we've got enough of a buffer within this dispenser. 18 stacks of bamboo reeds translates to 2 stacks of blocks. Is that enough? So that's the amount we have at double hopper speed. It's not quite double hopper speed. These two running together, it's slightly less than double hopper speed. I think 2 stacks at double hopper speed and then whatever afterwards at single hopper speed is fine. And I don't think it warrants having to split it like this. All right, so this is what we're choosing for the growth mechanism. I think that's going to give us the base results for the specific problem that we're looking at. All right, we're going to be having stuff growing super quickly, and we want to direct it into a water stream. So we don't have a hopper minecart underneath, so we can't have stuff landing on this block. That doesn't really fix it. And like I said, this is more an extension of this, but for space issues. I think we're going to land with the slime blocks. All right, this is the bamboo. It's going to grow onto this. So we want our piston at this level. I have no clue whether this stuff has a max height, but we're going to assume that it does. So I'm going to build it up all the way to the max height. I don't think you lose bone meal if you're empty or if you're triggering a dispenser and it's at full height. Since we're going to be running these off of clocks, you don't really want to waste bone meal. Can this piston work is the question. It can. Okay, that's awesome. I'm going to cover everything that gets touched by the piston, just so we don't accidentally put stuff next to the slime blocks at this point. Right? It's at max. And trigger this. All right, now we have our growth mechanism. Actually, we don't have our growth mechanism. We need another one of these. I think we move this one up because this needs to be here. And we need water on this side. And I don't want 2 separate blocks. That block is going to power both of them. And now we need hoppers into both. Filling those up is going to fill these 2 up equally. Apparently there was already some in there. There's going to be more of a buffer for this one but we can fix that in a second. I think for now, let's just see if we can power this with a observer clock. We might need to rethink the filling of this stuff. Maybe we do it from the top. That would clash with that, wouldn't it? Maybe I can eliminate some of those just so the discrepancy isn't quite as bad. It's still got a few extra, but I think it's slightly better now. We want an observer going into this block. We're not really working on compactness here at the moment. That doesn't quite work. Can we move this piston to the top? Because I think that would simplify things. For now, let's assume that's going to be out of the way. That's going to be moving. We could always remove it. All right, so the problem I am trying to solve at the moment is that it's seemingly quite difficult to keep this decently compact. I mean, you can always put the clock at the bottom, but I don't necessarily want to do that. So I've moved that there, and I've moved one block. I've removed one block. Hopefully that fixes it slightly. All right, now we can have an observer running into this block. That way. Piston, doing that. And then we just need a lever. Ooh, how's that happen then? Okay, the height that it grows to is not consistent. That's good to know. Okay, we've got a way to grow. We've got a way to harvest. The next thing we need is a way for this to run. And my first idea is that, but I get the feeling that that's not going to work. I mean, that's pumping it out, right? You're also going to get frames where it's trying to grow while the block is still over top, and you might be wasting bone meal that way. I think so this is the lowest we've seen it grow. Assuming that grows to at least this height. Can't really do that. It's just too slow. There's a little double tick. That's not going to work either, is it? Okay, that's a working design, but I think we can do better. So let me research what is the shortest pulse length that will keep a block attached to a sticky piston. And then if there's a way to make a clock. Okay, time to do some more research. All right, apparently 2-tick clocks are not as easy as I thought they would be. I thought it would be a simple build, but apparently it's quite a complex thing that people spend some time researching. So let's not steal anyone's design here, and let's go with the best thing that we can come up with. Right, this is where we stand at the moment. Let's turn that off. That's incredibly annoying. 8, 9, 10, 11, 12. So I think that's the minimum height they grow to. This observer is triggered, which goes along this redstone and then powers this piston. Now let me show you the kind of 2 modes that I've been considering here. That's mode number 1. But consider that bone meal is wasted for every tick that the slime block spends on top of the bamboo. So if the bamboo tries to grow and there's a block on top, it wastes the bone meal. So we don't want that. We want the slime block to be spending the least amount of time over top of this as possible. So the 2 configurations I have is the one I just showed, and then the next one is if I add 1 tick to this repeater, turn that back on, then it stays attached, right? It doesn't drop the slime block, but I'm not sure whether it spends more time or less time over the bamboo. Either way, I think both options are too much. So I kind of stumbled on this. What I did is I added that detects. That is updated when this is updated. I'm assuming 1 tick later. And then I think I had it this way. Like that. And now if we do this, it gets double pulsed. So I think it drops it and then retracts very quickly. I believe there might be 2 pulses going through here. I think that's what's happening. I'm not sure, but it seems to be spending less time on top of the bamboo. So I think this is what we're going to go for. Actually, if we remove this, does it have the same behavior? I think that would be a good test. That's definitely faster, right? I think that's definitely faster. Okay, that's what we're going to go with. Let's switch that off. One detection method sends a redstone pulse to the piston. I think it drops the line of slime blocks then. And then this second observer detects the first observer, sends a pulse to the same thing, and then reels it back in. All right, now we get to work on the collection system. Let's extend this. The pressure plate. Extend that by 1. And I think this should be working. Ooh, why are they not getting picked up? Are they getting powered? Oh, pressure plates. I'm stupid. For those of you that picked that up at the start, when I placed those down, that's one of the more questionable things I've ever done, I think. I was perplexed that we're going to replace that with a chest, because cakes are expensive. We don't necessarily need to use this top block, so we can probably remove it. At this point, it would be good to check whether this wraparound block here is actually needed. Turns out it's not, so we can also take this time to kind of clean up some areas that we have neglected. This does not need to be obsidian, so let me replace this. And that should do it. Leaves on the side is quite ugly, so let me replace that with glass. And there we go. Still ugly, but slightly less ugly. Ooh, actually, it would be good to turn this off as well. What I wouldn't mind doing is powering these as long as there's anything in there. Thinking about the logic, if that is on, we want this to be on. So we want a sticky piston extending from this block here. I want to see that piston retract the moment this empties out. Alright, that takes care of that. Personally, I wouldn't mind leaving this running at all times. It doesn't really matter to me, but that's just because I'm kind of irresponsible with lag. The top-down look, it's a relatively simple mechanism here, so it doesn't need too much explaining. Next thing is I'm going to move this chest off to the side, because I've kind of snookered myself with the spacing with that redstone there. When building the final version of this in my survival world, I will likely make this much more compact. This whole elbow could be moved all the way up to the end of this, and then you don't have as much space between here and there. For now, we'll just run a really long redstone line. I'm going to move this to the underside because that just looks like it might be easier. Okay, this observer powers that block and that powers both. So now when this chest is full, what happens to the signal strength? Second observer, that makes a clock. When it's active, it needs to be pushed away, so we can just put this here. That repeater will need to be there. You can just put 2 redstone like that. Alright, at a lower strength, it's on. Now, I'm going to fill this chest up and see at what point it turns off. Hasn't turned off yet. Still hasn't turned off yet. It's turned off. Okay, that's worked out quite well. An issue I'm just now noticing is that we're not really making use of these last 3 crafting units. I have an idea to fix that, so let's see if the idea makes it any better. Alright, my idea was to raise this up by 1 and have a hopper chain collecting the items out of the water, but these hoppers are facing this way, so it will be pushing items and being pulled from. So we should hopefully see some splitting. When the first one backs up, then we've got the first 3 working. If the second one backs up, we've got all of them working. It's not groundbreaking stuff, but I think it's a little bit better. In my opinion, this is something I would do if I were to actually build this farm in single player, which is the plan. So yeah, I think that's a nice little upgrade. The last thing we need to do is we need to unpower this stuff, meaning just power this piston or power this redstone when this block is being powered. In this state, we do want it to be off, so like that. Let's see what happens when this empties out. This turns on, that turns on, and this torches off, so this can harvest freely. The fact that this first hopper is obviously getting backed up is a bit of a problem. This farm's primary purpose is to keep this full. For a super smelter, that's never going to use more than let's say 9 stacks of blocks at a time. Even that's pushing it. But I would say I'm happy with the performance. Not a massive amount of overflow. I think I'm happy with that. For a first attempt, I don't think that's bad at all. So that's farm number 1 done, and we can definitely think of a few metrics to measure its success. First of all, bamboo block production, and second, probably bone meal use. All the other metrics are going to kind of be qualitative versus quantitative, and all the qualities of this are things that I kind of like. it's much more likely to fit inside of a base than the option we're going to look at next. That's one. Second, it's got a highly visual element that I quite like. And third, I don't know, I just think it's slightly more fun than some other things we could have come up with. Now it's time for farm number 2, and this one is going to need slightly more space, but I think we're going to build a small version. Full width, but reduced length. As far as I know, you should be able to expand the length of this one as far as you want. Going back to the board, this is just ultimate bamboo output. We just want loads of it, and we don't care when or how quick it is, or whether there's overflow, anything like that. We just want loads. The way to do that is with loads of bamboo plants and natural growth. Let's not waste any time with picking subsystems. I've already got them picked out. So first of all, we're just going to use this natural growth unit on its own, because this we can stack loads of next to each other. Second of all, none of these braking mechanisms really lends itself to a two-dimensional field. So I think we go with flying machine, because our options for a two-dimensional field like this is TNT and flying machine, and this looks like it's probably going to work out better. And then lastly, the hopper clock is a very popular option, but you know, I like observers, so I think we're going to do them instead. I think let's start off with just all the blocks that you need to build a flying machine and 2 stops at either end. We can do 9 slime blocks and a solid block at the end. You'll see why that's relevant in a second. So that's 10 blocks out this way, and then the piston that needs to get pushed and the observer. I'm pretty sure that push limit is 12 blocks, so this should be the max. You want the bamboo plants to be in the block below this, so let's go ahead and plant out a little field. We're not going to have this go very far, because this is just a test version. The full version, if you build this in survival, you'd probably want it to be much bigger, but we just need to prove that the concept works, i.e. a proof of concept. All right, there we have the field planted with no cheats. Now we can just manually send these off for now. So thinking ahead to the collection system, which our only option with these being solid blocks like this is hopper minecarts. Thinking ahead, it would be much easier to have all the unloading stations on a single side. So let's make that this side since we've got a bit more space. So basically what we want is whenever this flying machine reaches this spot, we just want to send it back out again. You can achieve that with an observer going into this block. When that reaches there, we'll get an update. Update will be sent through like that. And then we might need 2 more here to make this work. All right, let's see if that works. It did not work. Right, flying machine rebuilt. I think I may have switched the order here, so now we need to power this block with a pulse. I'm going to do that in a lazy way for now. That observer was facing the wrong way. This block at the end here will just complete the circuit. Apparently we needed a bit of a delay. Okay, there we go. That should be fine now. So every time it reaches this end, it'll just bounce straight back. I've kind of arbitrarily chosen the plant that's in line with this back piston here. Just moved it 8 blocks into the air. We'll just observe when that grows. And then one more, all the way down. So when this plant grows, it will trigger the flying machine, or when the plant grows into the space. And it bounces back. Right, all I've done now is I added some glass around the edges because the slime blocks were yeeting a bunch of bamboo over the edge here. They have despawned, never mind. And then I've done a little platform at the bottom in anticipation of having to do the pickup system. All right, that's looking good. So I think let's do the pickup system next. May have gone a bit overboard with the redstone blocks here. All right, so this is just the platform basically filled in. What I've got is fundamentally you need a powered rail because you need to be able to control when this leaves or not. Okay. So you got that powered rail, not connected to any other power rails. There needs to be a normal rail after it, as far as I know. So a powered rail that you have control over, and a hopper underneath the that powered rail that feeds into the hopper chain. That way, when this hopper minecart comes to a stop over this powered rail, it goes into this hopper and out into the chain. Then you can kind of make this bounce back and forth as many times as you want to. I've kind of arbitrarily chosen one hopper minecart for every 2 here, because when this becomes very, very long, that might be the kind of thing that you want. Plus 2s was just easy to do, so that's what I've gone for. What you want is from this powered rail, one line going away from the detection side, and then you've got to go make it go back. Then if you want to make it bounce back again, you can do that, or there is a way to do that. You're going to have to make it turn around there, but then you want the return rail to just lead onto the side of this powered rail, and then this hopper minecart will come to rest there until you can send it off again. So I've just copied that module as many times as was required here. After that, we need to power this rail whenever we want these things to go off. And the way we do that is with this block here, with a repeater going into each. So the first idea was to take it off of this observer, and you'll see what happens when I do that. Get sent off. Actually, that may be because I had removed these timings. Let's try that one more time. So I've just added 4 ticks to each arbitrarily, no real reason. All right, it gets popped off, but then all these rails get powered. They go off and they return, and they do have some stuff, but I think they're probably going to miss most of it. For example, they missed all of that, right? And we've got a bit of stuff floating around here. So it doesn't look like this is going to work. What we probably need to do is we need to find some other way. Going off the assumption that they will be faster than the flying machine, we can send a signal through this block, kind of like we did at the other side there. And I believe that should do it. It looks like it needs to detect redstone specifically. So let's add this repeater there, and then this redstone there, and then that might work. We need to move this there, I think. Let's try it again. And all of them got sent off. So let's see if we can grab everything that needs to be grabbed, all right? And by that I mean get all the bamboo. So chill out. All right, let's go. Get sent back. Now they will be sent twice, so that's something to keep in mind. But does everything get picked up? It looks like it, you know. I would say I'm happy with that. How long does it take to unload? That's the one thing I needed, and I clicked it away. Okay, trying to see how long it takes to unload all the goods. Is it still flowing into this hopper at the end here? Let's just do test. Ooh, okay. It's really backed up. So I think we've got a pretty quick system here. One more time, just because it's so satisfying. Gets bounced back, they get sent off again, everything gets picked up, and everything gets offloaded. Doesn't that just work fantastically? You know, I was very impressed with my little invention on this side that took hours of R&D, but this quick little flying machine design, it might have it beat, you know. I think we've touched on points 5 and 6 already. There's been a lot of building and testing, and we've iterated on quite a few points already. So at this point, we've got 2 designs that I'm happy with. I would be happy to build these, and realistically, kind of regardless of the rates, I'd be happy to call both of these a success. I think at this point it would probably be negligent for me to not run some performance numbers on these, just so I can get an idea of how the designs kind of compare, whether it's worth it to use all that bone meal, and how much the farm on my right hand side here needs to be scaled up to produce the same rates as the one behind. For all I know, it's already faster. So I'm going to pop some numbers up on the screen at this point. You can probably just pause to have a look. We'll kind of see what we're getting from both of these designs. I like both of them. I'm going to build both of them no matter what. So I'm not going to factor this into the design process because I've kind of grown attached to each here. But I think it would be good to see the results. Step number 6 there is iterate, and I think it's good to iterate in any capacity that we can. There's a lot of stuff that we can improve, and I'm not just talking about those bamboo farms behind me. Steps 1 to 6 that I've laid out here were my kind of interpretation of an existing systems design methodology, and I've adapted it to fit our needs here for Minecraft. This game is quite flexible. There's a lot of stuff we can do in here, but it's not nearly as flexible as the real world. Kind of during this process, I came to understand that a lot of these steps are more relevant and more important in real life. In real life, you've got a lot more theoretical design work, and you've got a lot more flexibility. You've got a lot more going into each subsystem. In a game like this, you've got quite a few ways of doing things, as you can see from all of this. But I'm kind of still on the fence whether all of these first few steps were necessary to achieve what we achieved here today. So at the start of the next episode, we will iterate on the method. I think it would be good to adjust the way we go about things going forward. And that's not just once, we'll do it as we need to, but I think the method that we have down there can definitely be improved, and it can definitely be adjusted to fit our needs better. But that's all stuff for next episode. But until then, I hope you guys learned something today, or at the very least, I hope you enjoyed watching me learning a bunch of stuff today, and I'll see you guys next time.